In this video, we are going to troubleshoot a heated oxygen sensor on a Nicky fuel system using the diagnosis charts and schematics provided from the manufacturer. Although this demonstration uses a Nicky fuel system, the testing methods covered in this video can be applied to virtually any heated oxygen sensor circuit found on all brands of equipment. By understanding the basic principles of an oxygen sensor and performing a few simple electrical checks with a digital multimeter, you'll be able to quickly determine whether the problem is with the oxygen sensor, the wiring, or the control circuit when the diagnostic software programs are not available. Before we dive into troubleshooting the oxygen sensor, it's important to verify that we're on the right track. Using the diagnostic chart in the service manual, we can confirm that the heated oxygen sensor is the correct component to investigate based on the engine symptoms or fault codes. Following the manufacturer's diagnostic procedure helps eliminate unnecessary parts replacement and ensures we're troubleshooting the actual cause of the engine issue.
Before we move on to troubleshooting the wiring harness, we can perform one simple sensor check that comes directly from the engine service manual. This quick test helps verify whether the sensor is operating correctly before spending time diagnosing the harness. Per the service manual, turn the ignition switch to the off position and disconnect the oxygen sensor from the engine harness. Set your digital multimeter to the ohm setting and measure the resistance between pins 2 and 3 of the oxygen sensor pigtail. The sensor resistance should be approximately 3.3 to 3.5 ohms. Keep in mind that this reading may vary slightly depending on your multimeter, so a small difference is acceptable. The primary goal of this test is to verify that the sensor is not shorted and does not have an open circuit or OL reading. If the sensor resistance is within specification, the oxygen sensor is most likely functioning correctly. Continue troubleshooting the engine wiring harness and ECM according to the service manual. Now that we have successfully tested the sensor per the service manual, it's time to check the engine wiring harness. These tests will confirm that the wiring between the oxygen sensor and the ECM is free of opens, shorts, or excessive resistance before moving on to ECM diagnostics. First, disconnect the battery and isolate all power sources from the engine wiring harness. Next, disconnect both the ECM connector and the oxygen sensor connector to isolate the circuit. Using the service manual ECM pinout sheet as your guide, check the resistance of each wire from the oxygen sensor connector to the corresponding terminal at the ECM connector. Measure each circuit end to end with your digital multimeter set to the ohm setting. Each circuit should measure less than 0.5 ohms, indicating good continuity. As with any continuity test, gently move the wiring harness while taking your measurements to check for intermittent opens caused by internally damaged wires. If all circuits pass these checks, move on to voltage checks on each wire per the reference values list located in the trouble diagnosis section in the engine service manual. Now we can perform voltage checks on each oxygen sensor wire using the reference values listed in the service manual. Pin 1 is the oxygen sensor signal wire. This 0.1 to 0.9 volt signal is monitored by the ECM and is used to determine the correct air-fuel mixture when the engine is operating in closed loop. As seen here, you can reference battery negative and measure the voltage on pin 1 with a multimeter or an oscilloscope during closed loop operation. The voltage should bounce up and down between 0.1 and 0.9 volts, trying to maintain a complete burn of approximately 0.45 volts. Pin 2 is the sensor 12-volt sensor supply. This voltage is provided by the ECM from pin 109 when the ignition switch is turned to the on position, then powers the oxygen sensor. Pin 3 is the sensor heater control wire. The ECM controls this circuit to energize the heater element, allowing the oxygen sensor to quickly reach its operating temperature of approximately 600 degrees Fahrenheit. Once the sensor reaches operating temperature, It maintains approximately 0.3 volts, then it can accurately monitor oxygen content in the exhaust and provide the feedback needed for the ECM to make fuel mixture adjustments during closed-loop operation. Pin 4 is the sensor ground circuit, providing the ground path required for proper sensor operation. While referencing battery positive, you can verify a good path to ground by probing pin 4 on the oxygen sensor harness.
By following these tests step by step, you've verified every major part of the heated oxygen sensor circuit, from the sensor and wiring to the power supply and ECU control circuit. Performing these checks in a logical order allows you to quickly determine whether the problem is a faulty component, an open or damaged wire, a poor connection, or a loss of power or ground. Remember, don't assume a component has failed until you've confirmed the circuit is operating correctly. Taking a systematic approach to electrical troubleshooting will save time, reduce unnecessary parts replacement, and ensure an accurate repair. Thanks for watching. Be sure to refer to the manufacturer's service manual for model-specific specifications and wiring diagrams, and we'll see you in the next troubleshooting video.